In this video, we will discuss the equation of continuity, and you know that we define the current that rate of flow of charge is, and you can say that our moving charges constitute the current. And you know that if we can say that if the current is moving, for example, if I am saying that current is moving from a given volume, from it means that there is must be decrease in the decrease of charge in that given volume, and we can assume that charge is neither created nor destroyed. You can say this is charge is conserved. So now, for example, here I am considering the simple this case of capacitor. In this capacitor, we have the two parallel plates, conducting plates, and you know that in capacitor there is dielectric media between these two plates. There is dielectric media, and you know that now question I will ask that, for example, why the current flows through the leads during charging or discharging of the capacitor when no current flow between the plates, between the capacitor plates. Say that there is dielectric media, it means there is no flow of current between these two plates, but at the through the leads there is flow of current. So what will the answer that I will give you the answer? That answer is that current flow is accompanied by the charge buildup on the plates. That you can say that if we are saying that it is current is flowing out from this plate, so it means that there is charge is building here, build up, and that is flowing out, and that will constitute the current. And this type of concept we can express in term of equation, or you can say this is the conservation of charge concept, and that we can write in the form of equation. So this is j dot dA, this is closed surface integral, and which is equal to the rate of change d by dt with negative sign, and this is volume integral rho into dV, and rho is representing the volume charge density, and this is dV is the volume, dA is the area element. So this is the mathematical way of writing the conservation of charge, and we will call this equation is equation of continuity. And another case, if I consider that if the region of integration is stationary, that does not change with the time, in that case we can rewrite this equation in this fashion, that d by dt I can put in within the integration sign, this volume integral. So this is known as the equation of continuity in the, this is integral form, you can see this is the integral form of equation of continuity. So this is, for example, now if I what is differential counterpart, or how I can write this in term in the differential form. For example, if I want to write the equation of, this is the way of writing in integral form. Theorem now I will use, which integral theorem I will use. So for this here I will use the uh, divergence theorem. We will using here divergence theorem. And what was that? So I want to clear one thing. Divergence theorem and Gauss law both are not same. They are different. This is theorem. Gauss law is law. So they are different. This is mathematical expression. For example, this relates surface integral. A is a physical quantity and D is the area element. I can write which is equivalent to volume integral divergence of A into dV. So this is the Gauss, this is divergence theorem. Gauss divergence theorem, you can say. Gauss divergence theorem. And if I use here, so instead of this left hand term J dot dA, if I use this Gauss divergence theorem, I can write this J, this Gauss divergence theorem, this quantity. I can write volume integral divergence of J into dV, and this quantity is equal to volume integral curly rho y curly t into dV. So now if you see that here both sides you have the same volume integral, so the area or volume of integration is same both sides. So if we solve this, we can get here divergence, this comes out to and minus rho y curly t. So this is the differential form. This is the differential form of equation of continuity. So this is differential form because the value of this volume integration both side comes out to be same, so that will get cancelled. We left with only divergence of J is equal to curly rho by curly t, and this is differential form. This is also in equation of continuity, but it is in the form of differential form, and this is also equation of continuity, and this is in the form of integral form. Sometimes some question may be asked, write down the equation of continuity in the integral form. Then you have to write this closed surface integral of J dot dA is equal to volume integral of with minus sign curly rho by curly t into dV, and this is the del dot J is equal to minus curly rho by curly t is the differential formula of the uh, equation of continuity. So this is all about the, or you can say this is representing that conservation of charge also, that why. So we have discussed in this. So this is all about the equation of continuity.